Tonight, we leave behind the familiar blue skies of Earth. We drift outward, past the warm light of the sun, past the pale deserts of Mars, past Jupiter's towering storms, and into the cool, dim reaches of the solar system. There, in the quiet darkness, a golden world turns slowly in the black. Saturn, from afar. Saturn is a vision of elegance, its pale yellow glow, its delicate rings, its steady presence in the sky. It is the second largest planet in our solar system, and yet it is a world of paradoxes. Despite being almost 10 times the diameter of Earth, Saturn is so light for its size that if there were a vast cosmic ocean large enough to hold it, it would float. Its low density comes from its composition. Saturn is made mostly of hydrogen and helium, the same gases that make up the Sun. But unlike the Sun, Saturn doesn't shine with its own light. It reflects the sunlight that reaches it, and deep within, it glows faintly with heat, left over from its formation, plus a little extra warmth generated by a curious process called helium rain. Scientists believe that deep in Saturn's atmosphere, helium droplets form and slowly sink toward the planet's center, releasing gravitational energy as heat. It is this subtle process, this gentle rain of one element through another, that helps keep Saturn warmer than it should be for its distance from the Sun. Look closer, and you'll see that Saturn is not a still world. Its upper clouds are wrapped in soft bands of cream, gold, and butterscotch, shaped by relentless winds. And these winds are not the breezes we know on Earth. They can scream at over 1,000 miles per hour at the equator, faster than the speed of sound in air. These high-speed jet streams are driven by Saturn's rapid rotation. A full day here lasts just over 10 hours because it spins so quickly. Saturn bulges at the equator and flattens slightly at the poles, giving it a distinct oblate shape. Every so often, Saturn's normally gentle appearance is interrupted by storms of staggering size. These are not small tempests, but planetary events, great churning ovals of white that can be larger than our entire Earth. One of the most famous, called the Great White Spot, appears roughly every 30 years. It's a megastorm that erupts with blinding clouds, encircling the planet in weeks, and can rage for months, before fading back into the endless flow of Saturn's atmosphere. Astronomers believe these storms are caused by warm air rising from deep within the planet, breaking through the cooler upper layers and releasing a torrent of cloud and lightning. Speaking of lightning, Saturn has some of the most powerful electrical storms in the solar system. When the Cassini spacecraft listened with its instruments, it heard long, rolling bursts of static that lasted for hours, the radio signature of lightning flashes inside the clouds. These bolts can be hundreds of times stronger than the ones we see in a summer thunderstorm on Earth. But as dramatic as the atmosphere can be, nothing about Saturn captures the imagination quite like its rings. They are, without question, the most breathtaking in the solar system. From far away, they look smooth and perfect, a single shimmering halo. But up close, the truth is even more astonishing. The rings are made of countless individual pieces, from grains of dust no bigger than sand, to ice boulders as large as mountains. Each particle orbits Saturn independently, held in a delicate balance between the planet's gravity and the speed of its motion. From above, the rings look almost solid. From the side, they nearly disappear because they are so thin. Most places, they are only about 30 to 300 feet thick, no more than the height of a city building. yet they stretch over 170,000 miles from one edge to the other. If Earth had rings like Saturn, they would fill our skies, casting long, shifting shadows over oceans and mountains, painting arcs of silver and gold across the night. And in daylight, the rings would glow softly, a constant reminder that our planet was part of something grand. Astronomers divide Saturn's main rings into 7 groups, named A through G, but even these are full of complexity. They are split into thousands of narrower ringlets, some braided together, some separated by mysterious gaps. These gaps are not empty space, but places where the gravity of Saturn's moons has swept the particles into new patterns. One such gap, the Cassini division, is over 3,000 miles wide, created by the tug of the moon Mimas. The particles in the rings are mostly water ice, pure, bright, and incredibly reflective. That's why the rings shine so brilliantly in sunlight, but not all are pristine. Some are coated with darker dust, likely from meteoroid impacts or material from distant moons. Over time, these grains get weathered by micrometeorite collisions and radiation, slowly changing the ring's brightness and color. The age of Saturn's rings remains a mystery. Some scientists think they are ancient, forming alongside Saturn over 4.5 billion years ago. Others believe they are much younger, perhaps just 100 million years old. The shattered remains of an icy moon or comet that wandered too close and was torn apart by Saturn's immense gravity. If that's true, the rings may be temporary, destined to fade as their particles spiral slowly into the planet. And here's something to ponder as we drift closer. Even though the rings look calm and unchanging, they are in constant motion. Particles collide, bounce, and shatter. New clumps form, only to break apart again. Waves ripple through the rings, created by the pull of moons or even impacts from passing debris. In a way, Saturn's rings are alive, not in the sense of biology, but as a dynamic, ever-shifting system. The sight of them, this impossibly thin, glittering halo suspended in the dark, is enough to make even the most seasoned scientist pause and simply watch. Because in the quiet of space, Saturn turns slowly beneath its crown, and the rings continue their ancient dance, unchanged in their beauty, even as the universe around them moves on. Beyond Saturn's shining rings, orbiting far and near, are more than 140 moons. Each one is a little world of its own, and together, they make Saturn a miniature solar system. Some are tiny, just captured chunks of rock and ice, no larger than a city block. Others are vast enough to have their own atmospheres, weather, and landscapes that could stretch the imagination. Among them all, one name stands above the rest: Titan. Titan is the largest of Saturn's moons, bigger even than the planet Mercury. From space, it looks like a soft orange sphere, its surface completely hidden by a thick, hazy atmosphere. And this atmosphere is unique in the solar system. It is made mostly of nitrogen, like Earth's, with traces of methane and other gases that give it its golden brown glow. If you could stand on Titan's surface, you would find the sky dim, more like twilight than midday. The air would be thick enough to feel heavy on your skin, and the temperature unbearably cold. Here, water is frozen harder than rock, and the rivers and lakes are not made of water at all, but liquid methane and ethane. Cassini and its companion probe, Huygens, revealed this strange, alien world to us in unprecedented detail. When Huygens descended through Titan's clouds in 2005, It sent back images of a landscape carved by flowing liquids, valleys, channels, and dark, glassy seas. It was like seeing a mirror of Earth, except everything familiar was made from something entirely different. Scientists believe Titan's methane cycle mirrors our water cycle. Methane evaporates from the lakes, forms clouds, rains back down, and erodes the surface over millions of years. It is a world where the chemistry of life might be possible, though life here, if it exists, would be nothing like life on Earth. From Titan, we drift outward to another remarkable moon, Enceladus. Enceladus is much smaller, only about 300 miles across, but it holds one of the most tantalizing secrets in the solar system. Its surface is brilliant white, the most reflective of any moon, because it is coated with fresh, clean ice, and this ice is constantly renewed by geysers. Yes, geysers, from fractures near Enceladus's south pole, nicknamed tiger stripes. Jets of water vapor and ice crystals shoot hundreds of miles into space. Cassini flew through these plumes, sampling their contents, and found water, salts, and even complex organic molecules. Beneath Enceladus's icy crust, scientists believe there is a global ocean of liquid water, kept warm by tidal forces from Saturn's gravity. An ocean under ice, venting into space, and rich in organic chemistry. It is one of the best places to search for life beyond Earth. Not all of Saturn's moons are serene. Some are shaped by violence. Take Mimas, a battered, frozen sphere, only 250 miles across, dominated by a single, colossal crater called Herschel. This impact scar, 80 miles wide, makes Mimas look eerily like the Death Star from Star Wars. If the asteroid that struck had been much larger, it might have shattered the moon completely. Then there is Iapetus, a moon of two faces. One hemisphere is as bright as snow, the other as dark as coal. Scientists think the dark side is coated with dust, swept up from another moon, while the bright side is made of clean ice. Iapetus also has an enormous ridge running along its equator, so tall and wide that it gives the moon the appearance of a walnut. Even smaller moons tell fascinating stories. Some, called shepherd moons, patrol the edges of Saturn's rings, using their gravity to keep the ring particles in place. One such moonpan looks like a flying saucer, thanks to a wide equatorial ridge built from ring material it has swept up over time. Others, like Hyperion, are irregular, porous, and strange, tumbling chaotically through space rather than rotating neatly like most moons. Hyperion's surface is pockmarked with deep craters, giving it the look of a sponge or a giant frozen honeycomb. But perhaps the most haunting of Saturn's moons is Tethys. On its surface lies a vast canyon, Ithaca Chasma, over 1,200 miles long, stretching across 3/4 of the moon's circumference. Imagine a fracture so large it could wrap around nearly the entire Earth, and you will have some sense of its scale. No one knows for sure how it formed, but one possibility is that an ancient ocean beneath Tethys froze solid, cracking the surface apart. Saturn's moons are not just worlds in their own right. They are active participants in shaping the planet's environment. They exchange material with the rings. They stir up waves and gaps. They even feed the rings themselves. Enceladus's geysers, for example, supply nearly all the material for Saturn's E-ring, a faint, broad band of icy particles that glows in scattered sunlight. From a distance, Saturn and its moons seem peaceful, like like a perfectly balanced system. But up close, you see a place alive with motion, with weather, geology, and change. The giant planet's gravity is a constant force, stretching and compressing its moons, shaping their orbits, and writing their histories in ice and rock. And though we have mapped these moons, photographed their surfaces, and tasted their atmospheres, we have barely scratched the surface of what they might hold. Somewhere, under the crust of Enceladus, in the methane seas of Titan, or in the silent valleys of a moon we have barely visited, the building blocks of life may wait, or life itself, in forms we cannot yet imagine. When Cassini ended its mission in 2017, it was not just a spacecraft falling into Saturn's clouds. It was the close of a chapter in our exploration of this magnificent planet and its family of moons. But the data it sent back, the images, the measurements, the stories, will keep scientists busy for decades. And one day, perhaps, humans will return to Saturn's realm, not as fleeting visitors on a robotic probe, but in ships of our own, to stand on the icy surface of Enceladus, or sail the methane seas of Titan. Until then, Saturn waits, turning slowly, its moons keeping silent watch. Before we leave Saturn behind for the night, we should spend some time with the messenger that revealed so much of its beauty. The Cassini-Huygens mission, launched in 1997, Cassini took a 7-year journey through the solar system, using the gravity of Venus, Earth, and Jupiter to slingshot itself toward Saturn. In July 2004, it entered orbit around the ringed planet, beginning more than a decade of discoveries. Cassini was more than a camera in the dark. It carried instruments to measure magnetic fields, study the chemistry of atmospheres, map surfaces hidden under clouds, and even taste the spray from Enceladus's geysers. It observed storms growing and fading in Saturn's atmosphere. It measured the thickness of the rings, and it revealed moons that no one had ever seen before. One of its most famous moments came in 2005, when it released the Huygens probe toward Titan. Huygens drifted down through that orange haze, parachutes slowing its fall, cameras and sensors recording every moment. When it touched down, it landed on a pebbly plain, beside what might once have been a methane stream. It sent back pictures of rounded stones, ice rocks, smoothed by ancient flowing liquid. It was the first, and so far, only landing in the outer solar system. Cassini's images became part of our collective imagination. The backlit view of Saturn's rings, sunlight shining through them like delicate lace, the tiny blue dot of Earth peeking out from beneath Saturn's shadow, a reminder of how small and fragile our world is. But all missions must end. By 2017, Cassini's fuel was running low. Rather than risk the spacecraft crashing into a moon that might harbor life, NASA chose to send Cassini into Saturn itself, ensuring it would burn up harmlessly in the atmosphere. In its final months, Cassini performed daring grand finale orbits, diving between the planet and the innermost rings, gathering data no other spacecraft had ever collected. On September 15th, 2017, it sent its last signal as it plunged into Saturn's clouds and was torn apart. It was a scientific triumph, and also a deeply human moment. The end of a long journey, the goodbye of a machine that had become a companion to so many who followed its travels. But Saturn's story is far older than our spacecraft. For as long as humans have looked up, Saturn has been there, moving slowly against the backdrop of stars. To the ancient Babylonians, Saturn was Ninurta, a god of agriculture and healing. The Romans named it after Saturnus, their god of sowing and time, whose festival, Saturnalia, was a season of feasting and gift-giving. In Hindu tradition, the planet is Shani, a powerful and sometimes stern deity who delivers the consequences of one's actions. In Western astrology, Saturn is the taskmaster planet, associated with discipline, boundaries, and the passage of time. When astrologers speak of a Saturn return, they mean the roughly 29-year period it takes for the planet to complete one orbit, a milestone often linked to personal growth and change. Its rings, too, have inspired myths. Some saw them as a crown, others as a celestial halo. It wasn't until Galileo's first telescope in 1610 that we even knew the rings existed, though he couldn't make sense of them at first, thinking they were two large moons fixed on either side. Only later, with better optics, did Christian Huygens realize the truth: a thin, flat ring encircling the planet. The science of Saturn has not erased its poetry, even now, knowing that the rings are mostly water ice, knowing they may be no more than a few 100 million years old. They remain one of the most breathtaking sights in the cosmos. And the story is not over. New missions are being planned. NASA's Dragonfly rotorcraft, a nuclear-powered drone, is set to explore Titan in the 2030s. It will fly from place to place, sampling the chemistry of dunes and frozen plains, searching for the precursors to life. Proposals exist for missions to Enceladus, to dive once more through its gazers, or even land and drill into the ice, searching for life in its hidden ocean. Others dream of sending orbiters equipped with radar to map Titan's seas, or probes that could float on liquid methane, sailing in the alien stillness. Someday, human explorers may come. They might live in domed habitats on Titan, where the thick atmosphere shields them from radiation, and the gravity is low enough that they could strap on wings and fly under their own power. Or they could build research stations on Enceladus, harvesting water ice for fuel and sending submersibles into the warm ocean below. But those are dreams for another century. For now, we have our telescopes, our spacecraft, and our imagination. When you picture Saturn tonight, try to see it as Cassini did, a golden globe, wrapped in bands of storm and shadow, encircled by vast rings that catch the sunlight like glass. Dozens of moons turning in slow, graceful orbits, each one unique, each one with its own story to tell. A place so far away that light from the sun takes over an hour to reach it, yet a place we have touched with our minds and our machines. Close your eyes and imagine you are there, floating above the cloud tops, the rings arching out in both directions, curving away until they vanish into the distance. Below you, lightning flashes deep in the planet's storms, momentary sparks in the endless swirl. Above, the black of space is speckled with stars, and somewhere out there, a faint blue dot is home. In the quiet of this vision, Saturn turns, just as it has for billions of years, waiting for the next traveler to arrive. And maybe